heard the legend of the 10x programmer, this person who only makes 8 times the amount of money you do, but produces 10 times the output, and therefore the company hiring him or her is better off instead of hiring 10 normal programmers. In today's episode, we will actually examine the mythology or the truth or methodologies behind such an assertion. Is it true? If so, what are these people doing? And can they be doing it better? So if you kind of think about it logically, if somebody is going to produce 10 times the amount of code or output as a normal programmer does, they can't possibly be typing 10 times faster. That's humanly not possible. So either they generate the code, so they write a small amount of metadata and run it through a code generator and generate all this massive amounts of code, or they use some type of meta programming where the code is generated on the fly. So, if you kind of narrow down all the possibilities, these are the two techniques that you come down to. And let's actually look into what these techniques are and if one is better than the other. So let's look at the first of these programming techniques, the code generation. So you got a task that's extremely boring, repetitive, and sucks the life out of your enthusiasm for programming, but you still have to get it done on time. So what do? Of course, you write a code generator. So let's see. I want to pick a code generator that I wrote a few years ago. It's called FlatC. The name comes from interface definition file language called Flatbuffers. Flatbuffers is a project from Google. It's for transporting bytes across the network in a backward compatible way, typically used by gamers. But I found the interface definition language interesting. Could be used to write many different types of data structures, and then you could parse those data structures and generate code in several different programming languages. So the Flatbuffer project itself includes such a tool that's written in C, and I wrote one in Python a few years ago because I found it more flexible. I could get it to do more things. So let's look at what does this thing look like. So I want to show you an example Flatbuffer file. So this one is a file that describes the data structures involved in the Raft distributed consensus algorithm. It has a few constants, structures, and various log entries and things like that. And let's say you want to use this interface definition language. Maybe your client is written in Swift programming language and your server is written in the Python programming language. So what you can do is you can run this through the FlatC compiler, which is a code generator in this case. And there you go. So you got a module that's written in Python that mirrors the same data structures and constants. And you could do the same thing in a different programming language like Swift, and you get a Swift definition of the same data structures now. So if you had to kind of write this by hand 10 times, you would have probably taken 10 times the amount of effort. And because this tool supports a wide range of programming languages and data file formats such as YAML as well, you can get your work done faster. Now for the second highly productive programmer technique, metaprogramming. I want to show you an example of a project that's about metaprogramming. It's called fquery. fquery is a GraphQL compatible object relational mapper that allows you to operate entirely in the object domain. But if you want to talk to a relational database, you can. You can use Django, a popular Python-based server-side programming framework, I would say. So what happens when you program in Django is that you don't directly write SQL. So you write your data structures, whether it's a user or an account or a department and an employee. You write those things using a very database-oriented, relational database-oriented flavor of Python. It doesn't look anything like what a normal Python programmer would write otherwise if the database did not exist. So in metaprogramming based techniques, what you do is that you would model your data structures as a data class. So data class is a Python 3.8 based techniques. It allows you to define a user who has like two attributes. Name is a string, age is an integer. So this is all standard Python. But then what I've done here is that I've created a decorator @node, and what this @node does is behind the scenes it generates all the glue code needed to connect this object to a database. In other words, the code generation is happening in this case, but it's happening behind the scenes without you noticing it. There is no generated file. The code generator runs when you run this code, right? So that's the benefit of this technique. And it's not just @node, there's @edge, which is a decorator that is provided by this package. There are a few standard Python decorators like @property, @static method. Those are nothing new. If you're a Python programmer, you already know about them. @query, I think this is where all the heavy lifting happens. When you use the @query decorator on top of a class, it magically gets attributes or functions like filter, group by, things like that. So once you have this code, you could write queries that look like this. You have a user query, you get their friends, and you get the names and the IDs of the friends, and then you limit the number of friends to 3, and you request the output in the JSON format. And the output of this query is like not flat, not like a relational database, but it's like a nested JSON, sort of like GraphQL. In fact, once you write these data classes, you can plug them into a GraphQL server. I've used the Strawberry GraphQL for a couple of examples, or you could add yet another decorator. So this is called @model to generate a Django model. So once you use the @model decorator, Django won't know if you want, if you use the native Django way of writing a model, or you use this fquery based things. So this technique is also called aspect-oriented programming. So if you have a function, let's say, that adds 2 integers, so let's say you have something that looks like add a is an int, b is an int, and then you return a plus b. So this is what, as a programmer, you would like to write. But in practice, before you can push this code into production, maybe somebody asks you to log the parameters. They want to make sure that you're allowed to do certain things. Is are you allowed to add a and b? Maybe you have an access control framework. Maybe you have a privacy framework if you're into social media and things like that, where you want to check if adding a and b violates the privacy policy that the user A has instituted for themselves, or maybe they have made some choices. And so in the end, your logic of adding A and B is obscured by all these other concerns. So what you do instead is you kind of move all these things into decorators, like and maybe you do GraphQL, and these are like you can keep on stacking them one on top of the other. So this style of programming still generates the code, but the where the code is generated is completely hidden from the end user. I hope you enjoyed learning about code generation and metaprogramming. Now let's talk about which one is better, and if you want to be a 10x programmer, do you want to pick code generation or metaprogramming as your go-to weapon? So if you are working with different programming languages, different kinds of tools that you have no control over, then code generation is all you've got. So you generate code in whatever format this other compiler, other tool expects, and feed the generated code to the tool, and mark yourself done, and write a great self-review, and there you go with your bonus and your extra stock. Or if you want to kind of try this metaprogramming thing, the biggest benefit is that you don't have to deal with your build system. So whether it's Makefiles or Bazel or Maven or any one of these tools, once you start doing code generation, you have to integrate the code generation step, teach this build system which ones are source files, which ones are generated files, when they should be cleaned up and where they should exist, and what are the linters, and this entire new world of complexity. You don't have to deal with it if you use metaprogramming. So then why don't people use metaprogramming all the time? I would say the biggest obstacle in adopting metaprogramming is that if you go too meta, you end up with a very slow build system. So if you have looked at header only template based libraries in C++, those things work, but they take forever to compile, because when you run the compiler, they're like trying to generate the code behind the scenes. There's people writing Sudoku solvers and game editors, and there's all kinds of fun projects that are possible with metaprogramming, but they tend to be slow because the compilation is happening when you run the tool. Whereas with code generators, you run the code generator once, you got your output, and beyond that, nobody knows if you generated it from a script or you wrote it by hand. So it looks and works exactly the same. So slow builds are a big issue. So this is where people who like C or people who like Go, who are averse to having a lot of compile time complexity, a complex programming language which has all these decorators and metaprogramming tools. So you look at the code, you see this simple decorator, but behind it lies like 10,000 lines of code that you don't know about. So the complexity bothers some, so they would rather generate the code, have the code checked in. So once you have your generated code, you can look at that code. It's very simple, it's obvious what it's doing, and some people even check that code in, even if it's generated. Checking in generated code has its own shortcomings, which is that every time you make a change to the source, you have to rerun the code generator, and when you commit, it's not just the source changes that show up in the diff, it's also the generated code, and that can make code reviews kind of painful. So they both have pros and cons. I hope you enjoyed learning about them, and maybe you have another 10x programmer technique that I don't know about. Maybe you can share your technique in the comments below, and thank you for watching.